enthusiast, welcome back to Data Science Utopia. Today, we're diving into the wild world of machine learning. So grab your snack and let's get learning. So what is machine learning? Machine learning is utilized in performing a wide array of tasks, including face recognition on smartphones, speech recognition to assistants like Siri and Alexa, and recommendation systems on platforms such as Amazon and Netflix, among many others. But what exactly is machine learning? Traditionally, we use computer and machine to perform repetitive tasks. So the traditional way to work on computers is to provide it with some input data, a set of instructions on how to accomplish a task, then the computer will follow the instructions and provide us with the output data or the results on the task. In 959, Arthur Samuel introduced a new approach. He wondered if computers would infer a logic instead of being given the instructions to follow. So, he wondered, what if we gave a computer the input data and the output results? Could a computer figure out the best set of instructions that will give the output based on the input data? Treat this, let's say we feed the computer the numbers on the table as input, as well as the expected result on the left as output data. He wanted to know if the computer could find a simple linear combination of the input values is a close approximation of the output values. This is what we mean by a computer or machine is learning. After training a model that has learned the appropriate set of instructions, we can simply provide it with input data and it will apply these instructions to produce the corresponding output results. What we just discussed is a type of machine learning. It's called supervised learning. Supervised learning is useful in solving problems like image classification, spam detection, sentiment analysis, and predicting house prices. Another type of machine learning is unsupervised learning. With unsupervised learning, we simply ask the machine to identify any hidden patterns or relationships that exist in the input data. Some applications of unsupervised learning are customer segmentation, anomaly detection, market basket analysis, and gene clustering in bioinformatics. The third type of machine learning is reinforcement learning. This approach involves two main entities: the agent and the environment. The agent learns how to perform a task by repeatedly taking actions and receiving immediate feedback, either positive or negative, from the environment. Through numerous cycles of action and feedback, the agent eventually discovered the optimal sequence of actions needed to achieve the task. Reinforcement learning is widely used in computer game engines, robotics, and self-driving cars. Now, let's dig deeper by finding out what is not machine learning. The field of machine learning and artificial intelligence is filled with specialized terms such as unsupervised learning, statistical learning, data mining, optimization, large language models, deep learning, statistics, supervised learning, reinforcement learning, data science, and generative AI, among others. What do these terms actually mean? Are they synonymous or they differ? How do they interrelate? First, let's compare statistics to machine learning. Many people think that machine learning is a field of statistics. Yes, understanding statistics helps a lot in building models, but there is more to machine learning than statistical concepts. Machine learning draws from information theory, calculus, algebra, engineering, and even biology. It's crucial to highlight that the objectives of machine learning often differ from basic statistical modeling. Machine learning focuses mainly on making predictions and forecasting data based on past events. On the other hand, statistical models primarily concentrate on understanding the relationship between variables known as inference. Statistical modeling, the goal is to comprehend how changes in one variable impact another. The shared technique between machine learning and statistical modeling are commonly referred to as statistical learning. Let's take a closer look at the terms machine learning, data mining, and optimization. These concepts are intricately linked and represent specific areas within the vast field of data science. Just like the distinction between machine learning and statistics, the variance between machine learning and data mining lies in their fundamental goals. Machine learning emphasizes prediction by utilizing known data attributes, while data mining aims to reveal new patterns in data. In the business analytics sphere, machine learning is often associated with predictive analysis, data mining with descriptive analytics, and optimization with prospective analysis. Descriptive analytics identifies patterns in past data. Predictive analytics forecasts future results, and Prospective analytics suggests the optimal course of action. Moving forward, let's explore the remaining terms. Deep learning is a type of machine learning that falls under supervised machine learning. Supervised machine learning, reinforcement learning, and unsupervised learning are the main branches in the field of machine learning. Now, we need to highlight that machine learning is not the same thing as artificial intelligence or AI. Machine learning is a subfield of artificial intelligence. In other words, all machine learning is AI, but not all AI are machine learning. Artificial intelligence is a vast area within computer science focused on simulating intelligent behavior in computers. This encompasses tasks such as visual perception, speech recognition, decision making, and language translation. AI models can be categorized in various ways, one of which is based on the functions they perform. With this perspective, AI models can be classified as either discriminative or generative, known respectively as discriminative AI or generative AI. To illustrate the distinction between these two approaches, let's use the context of image analysis. Discriminative AI models focus on categorizing input data or predicting future outcomes based on historical data. For example, given images of various animals, a discriminative model can accurately label each image as a dog, cat, or a bird. It determines the probability that a particular image belongs to a certain category based on its features. The machine learning approaches introduced in this course all fall under the discriminative AI umbrella. Generative models, in contrast, are designed to create new content based on user input. These models can generate innovative text, complete sentences, and even craft entirely new piece of writing. One of the most notable generative AI methodologies gaining significant attention today is large language models. LLMs excel in understanding and generating human-like text based on the input or prompt they receive.